Perovskite refers to any kind of material that consists of a similar crystal structure as calcium titanate. The ideal perovskite structure usually has a crystal structure of cubic or tetragonal, represented by the general formula of AbO3, where A and B are cations, and O is the ions that bond both cations. On the other hand, double perovskites were introduced in the configuration of A2BbO6, where A or A consisted of alkaline earth or rare earth metals and B or B consisted of transition metals, with the rock salt-like structure of BO6 and BO6 units in the crystal. Various substitutions or doping can be performed in the B site of the perovskite to elevate the compound's properties. The compound used in this study is SR2NiWO6, and it acts as a dielectric. Previous research has stated that this compound possessed high values of dielectric constant at 308 with a low dielectric loss, 0.06 at a frequency of 1 kHz. Dielectric material is an electrical insulator that can be polarized by an applied electrical field. When the dielectric material is placed in an electrical field, electrical charges did not flow within the materials as they do in electrical conductor. The charges slightly shift from their average equilibrium positions, causing dielectric polarization. There are two problems in this study, which are, the tremendous trend in smart technology applications has captured the interest among researchers, hence increasing the demand in double perovskite study. Other than that, previous study has revealed that a few of double perovskite material has low value of dielectric constant, which could be enhanced by doping to apply in energy storage applications. The objectives of this study are to synthesize calcium-doped tungstate-based double perovskite with X equals 0 and 0.02 using solid-state reaction method, due to simple in handling and low cost. The second objective is to study the correlation of grain size effect with the dielectric properties of double perovskite. The motivation for this research is to encourage more researchers to involve in Industrial Revolution 4.0. In addition, this study could enrich the research and development on dielectric field. It also has a great potential in creating a career opportunity for B40 groups. Since the study on double perovskite remains silently undiscovered for a few decades, it is intriguing to further investigate the properties of this compound, as it has a high potential in producing dielectric material in future. The method used to synthesize the compound is solid-state reaction. First, the chemical powder of strontium carbonate, nickel oxide, tungsten oxide and calcium carbonate were weighed in stoichiometric ratio using weighing balance. Then, the mixtures were ground using agate mortar and pestle for about 2 hours until it became homogeneous. The mixture underwent calcination process at 900 degrees Celsius for 24 hours. The calcinated powder then were pressed into a pellet using hydraulic pressure and sintered at 1100 degrees Celsius for another 24 hours. The sintered pellet underwent several characterizations to study the properties of the compound. The results obtained from SEM and dielectric measurement has shown that as Ca2+ were doped into the compound, the grain size decreased and increased the grain boundaries. This behavior has caused the restriction on charge hopping, leading to the localization of charge carrier, thus enhancing the dielectric properties. Double perovskites have been widely studied due to its huge potential in technological applications. They have a wide range of usage such as capacitors, solar panel, DC block and liquid crystal display, LED.